SAERI's recent report has investigated the Falkland Islands' abundance of blue carbon. These are stores of carbon in marine ecosystems. For example, when ocean life dies, the carbon within the remains is stored on the ocean floor. This carbon is locked away and taken out of the carbon cycle for potentially hundreds to thousands of years.
Our oceans take in about 50 times more CO2 than our atmosphere, and it goes through different pathways to get to that point of sequestration. For example, along our coasts we have these beautiful kelp forests, and those are very significant carbon stores in the world. And then in what's known as the mesophotic habitats, so that's our areas between roughly 50 to 150 metres. We've found deep sea corals, for example, and rhodolith beds, which are a type of coralline algae. And so these are new calcifying habitats for the Falkland Islands that we've only recently had any insight into. And if we can understand those places more, we can hopefully actually get to the point where we could quantify how vulnerable our carbon stores and sinks are, but also get to the point where we can talk about them in broader applications for climate change as well.
Preservation of these habitats could also help protect the Falklands fishing industry.
Something that I've found really interesting is, so the lens is to look at it through how it's important in terms of blue carbon, but you're also gaining a broader understanding of these ecosystems across the board. And the kelp forests, for example, so we talk in terms of ecosystem services. So one of those many services is that they're nursery grounds and habitats for commercial and non-commercially important fish species. Maintaining those areas is incredibly important for sustainable fisheries long term.
From a geological perspective, the untouched nature of the Falkland Islands environment has improved its ability to store carbon and to be a place where marine life can thrive.
So we created this kind of infographic to explain patterns at South Georgia during the last glacial maximum, but it's been quite useful in explaining why the Falkland Islands is important as well, because so if you look at this, as in the last glacial maximum, when there was a lot more ice at places like South Georgia, for example, when we would come and sample, we would find a higher level of biodiversity where there wasn't ice scour, and then where animals could colonise, you find not so much biodiversity. And this is a really good analogy for the Falkland Islands, because the Falklands was non-glaciated during this time, is the hypothesis. And so what you have is this really beautiful example of an area that was entirely a refuge for this type of biodiversity during that time. And so it means that it's potentially been there for a lot longer than places like the Antarctic and sub-Antarctic, and as a consequence older, higher biodiversity, and potentially very unique as well, and highly adapted to this environment, which makes it globally quite important as well and worthy of conservation protection.
These carbon stores could also provide a financial opportunity for the Falkland Islands, with the potential for a carbon credit scheme that could see stores of carbon sold on the global carbon offsetting market.
It's quite a complex subject, and people are in the process here, I think, of learning about that. And as their knowledge increases, so the schemes that can benefit the Falklands will become evident and be put in place, I hope. I hope this will follow on from quantifying the issue, and then looking into a proper carbon credit scheme linked to the Falkland Island reserves.
SAERI's report will serve as a basis for much more exploration and understanding of the Falklands stores of undersea carbon. Coupled with the new designation of marine managed areas, it looks to be a promising step towards better understanding and better protection of the Falklands marine environment.